Good morning, students. Welcome to JP Physics Academy. Students, yesterday in the last video, we started the new lesson, that is work and energy. We discussed the definition of the work, types of the work, and the factors affecting the work. Okay, students, let me tell you a small notice for you. We started in the last video. Before the last video, we started the measurements lesson, and yesterday onwards we are discussing about the work and energy. So students, please remember this one. So I can frame that videos about these two lessons continuously. Don't be confused. Is it clear, students? Now today let's go to discuss about the units of the work and about the power. Okay, students, let's go to discuss now. So first of all, what is the formula? What is the formula of the work? Students, the last video we discussed that work is nothing but when we apply some force on the object, it displaces. Okay, when we apply some force on any object, if it displaces, then we can say some work is done on the object. So based on the definition, so we can write the work W is equals to force into distance or displacement. Students, in the case of when we discuss about the work, so in this case distance and displacement both of them are same. Okay, then the work is equals to force into distance. What does it mean, Sandy? The product of force and distance is called work, or the general definition is when we apply some force on the body, if it displaces, then we can say some work is done on the object. Okay, even though if you apply some force on the object, if it doesn't displaces, then we can't say some work is done on the object. That is zero work done. Okay, this is the general formula of the work. Then let us try to find out the units of the work done. Okay, now students, remember this one. If you want to find out the units of any physical quantity in entire physics, first we should know that the general formula of the respective physical quantity. So in this case we are discussing about the work. We are trying to find out the work units. That's why in this case, if you want to find out the CGS unit of the work. In the case of CGS unit of the work, if you want to find out the CGS unit of the work, first we should know the CGS unit of the force and CGS unit of the distance. What is the CGS unit of the force and the dyne? Dyne is the CGS unit of the force into what is the CGS unit of the distance? Centimeter. So students, in this case, don't put the into and just make it as a point or hyphen. Okay, sir. The CGS unit of the distance, the CGS unit of the work is dyne centimeters. It is also referred as erg. It is also referred as erg. Dyne centimeter is also called erg. Okay. The next one is, let us try to find out the MKS unit of the work. If you want to find out the MKS unit of the work, first we should know the MKS unit of the force and MKS unit of the distance. What is the MKS unit of the force, students? Newton into what is the MKS unit of the distance? Meter. So Newton meter is the MKS unit of the work. It is also referred as joule. Means the CGS unit of the work is erg and the MKS unit of the work is joule. Now let us find out the relation between joule and erg. 1 joule is equals to 10 power 7 erg. Students, this is the standard value. At the same time, the relation between joule and erg. Let us find out how this 1 joule is equals to 10 power 7 erg. Okay. So 1 joule is equal, how do we write this one? 1 joule is, how do we write this one? 1 Newton into 1 meter. So means when 1 Newton force applied on the body, if it displaces 1 meter, then we can say 1 joule work is done on the object. Okay. At the same time, the CGS system, when 1 dyne force acts on the body, if it displaces 1 centimeter, then we can say 1 erg amount of work is done on the object. Students, is it clear, Andy? So let us find out that this value 1 joule is equals to 1 Newton. So let us convert this value from MK system to CGS system. That is only we are doing here. So 1 Newton is equal how many times? 10 power 5 times. 10 power 5 times into 1 meter is equal how many centimeters, and 10 power 2. I mean 100 centimeters. We can write in the power factors as 10 square. So 10 power 1 Newton is equal to 10 power 5 times, and 1 meter is equal to 10 square centimeters. Now 1 joule is equals to 1 joule is equals to, so 1 joule is equals to 10 power 5. Bases are same, powers we have to add. 10 power 5 into 10 power 2 is equals to 10 power 7 dyne centimeters. Dyne centimeters. So 1 joule is equals to 1 joule is equals to 10 power 7. Friends, this dyne centimeters is also, the dyne centimeter is also referred as, erg. Erg means 1 joule is equals to 10 power 7 ergs. Is it clear, students? Once again, we are discussing about the formula of the work and the units of the work. So what is the formula of the work? According to the definition of the work, when we apply some force on the object, if it displaces, then we can say some work is done on the object. According to the definition, this is the formula indeed. Work is equal to force into distance. Of course, one more definition also there. The product of force into distance. The short we write as W is equals to Fs. W is equals to Fs. Sorry. And one more formula also there. W is equals to Fs cos theta. W is equals to Fs cos theta. What does it mean? When the angle makes between distance and the force, applied force, then we have to consider this formula. Okay, na? For example, so there is a surface. A toy car which moves on the floor or the surface. A child, he pulls the body like this. A child pulls the toy towards himself. Okay. Then this is the actual direction of the force. So here this is the applied force, this is the force direction, and this is the motion of the body direction. Both of them are same direction, this is the positive work only. But here between applied force and the distance, between the applied force and distance, some angle is making between them. That's why in this case angle is theta. In this kind of situations, we should consider the theta value, means angle value also. That's why the formula is W is equal to Fs cos theta. Students, with this is general formula of the work, and this is the general formula of the work when the angle makes between the distance and the applied force. Is it clear, students? Then let us find out the units of the work. What is the units of the work here? The series system. The series unit of the work is, if you want to find the series unit of the work, then the series unit of the force is dyne, the series unit of the distance is centimeters. Dyne centimeter is the CGS unit of the work, and it is also referred as erg. Okay. And the MKS system, MKS unit of the work is Newton meter, which is also referred as joule. Now this is the relation between joule and erg. 1 joule is equal to 10 power 7 ergs. Then we found this 1 joule is equal to 1 Newton into 1 meter, means when 1 Newton of force, 1 Newton amount of force applied on the body, it displaces 1 meter, then we can say 1 joule work is done on the object. So 1 joule is equal to 1 Newton is equal to 10 power 5 times and 1 meter is equal to 100 centimeters. If you write it in the power factors, we can write it as 10 square centimeters. Then 1 joule is equals 10 power 7 because of 10 power plus 5 into 10 power plus 2. So bases are same, powers we have to add. So 10 power 7 10 centimeters. 1 joule is equal to 10 power 7. In the place of 10 centimeters is also called erg. That's why 1 joule is equal to 10 power 7 ergs. Is it clear, students? So in the next video we are going to discuss about the power and the, okay na? So this is it today class. If you like this video, please watch and share and like this video, and please don't forget to subscribe our channel, and please click on the bell icon for getting the first notification. Okay students, have a great day. Bye.